So what we're looking at in chapter 3 is parallel and perpendicular lines. Parallel and perpendicular lines, and that's going to be the key part of chapter 3. We will finish chapter 3 next week. We're going to be completely done with chapter 3 by the end of next week.
Really?
Mm-hmm.
Like tests and everything?
Tests will be after we get back from the break, but we'll finish all the lessons by next week. Yes?
I will not be here on the 13th next week because of my dad's surgery. I'll be up in Boston.
Okay. Just remind me when we get there.
The week of the 26th, I won't be here. I'll be in Indianapolis with.
You'll remind me when we get closer. All right, guys. Now, the first thing we're looking at in this core concept is parallel lines, skew lines, and parallel planes. Well, parallel lines are what? Two lines that never cross or never intersect, yes? But the other key thing is, because we don't normally talk about this, is that they are parallel lines that are lines that do not intersect and are coplanar. They're contained within the same plane. Because most of the time, especially in Algebra 1, when we talked about parallel lines, well, we were talking about on a coordinate plane. So we didn't have to state the fact that they are in the same plane because we only worked in one plane. But here, when we talk about two lines being parallel, they do not intersect and they are in the same plane. Skew lines, two lines are skew when they do not intersect and are not coplanar. So just because two lines do not intersect does not mean that they are skew. Because if they do not intersect and are in the same plane, they are parallel. But if they do not intersect and are not in the same plane, then they are skew. And we can also have two planes being parallel if they never intersect. So we can have planes that are parallel as well. Now we do have our parallel sign symbol.
Is that parallel? Oh. Did we learn that in algebra?
Mm-hmm. And perpendicular is our upside down T. Now, think of each segment in the figure as part of a line. Which lines or planes appear to fit the description? Line parallel to CD and containing the point A. So we need to name a line that is parallel to CD and contains the point A. AB is parallel to CD and contains the point A. Would the line EF work?
How does it have the line A contain?
Mm-hmm.
Oh,
Would EF be parallel to CD?
Yeah, but it doesn't
contain point A, because it is contained in the plane. How about line HG? Is HG parallel to DC?
no. Go across.
No, because as the figure that we have, we don't have a plane that contains it. We would have to create a plane going diagonally down because it's not contained in the same plane, because our planes are along the edges of the cube. And it doesn't contain point A. Now, I will tell you the homework assignment will have the same thing. It's going to contain a point, but the point that they want is in the description in the very top, the instructions. It's not in each of the problems. Okay. Any other questions on part A? Part B, lines skew to CD and contains the point A. So AB would not work because that's parallel, contained in the same plane, yes? So skew means that they do not intersect and are what? They're not what? They're not on the same plane. So what would be a line that goes through A Yes. Because is point H contained within the plane? No. So according to our line plane, or let's see here. Yeah, our line plane postulate from last chapter. Because if 2 points are contained within the plane, then the line containing those 2 points is also in the plane. Well, H is not in the plane. So line AH would not be in the plane either. There's one more. Exactly. Because if you notice, we do have a line going from A to G. So that line, because since G is not contained in the plane, line AG would not be in the plane also. That's it. Questions on this here? On what part? So 2 lines are parallel if what? 2 things. And? Okay. So what plane? So CD. What other plane? Well, the plane is this entire top. So AB would be contained. Now for skew, we can't have a line contained in the plane, so we're talking about, or C, lines perpendicular. Yes. Containing point A, so perpendicular. Now, if we listed all the perpendicular, as long as this is a cube and we have all right angles, if we just wanted perpendicular, DE would work, CF would work, CB would work. Any of those would be perpendicular, because as long as they intersect and form a right angle. AB would be parallel to CD. We're running perpendicular. Okay. Any questions on C before we look at D? D, plane or planes parallel to EFG. EFG. Plane ADC? Yes. Or we could say ABC, ADB. Because we just need 3 points that are naming the top plane. Any of those would work. So the last one that we'll look at on this page is name the line or lines through point F that appear to skew to EH. CF. Because EH is right here. Point F is back here, so the only line that would skew to it would be going up and down. FG is on the same plane, so even though they don't intersect, that would be considered parallel, because same plane and not intersecting is parallel. AH would intersect line EH at point H. So it wouldn't be skew. Skew does not intersect. Perpendicular would. So AH would be perpendicular. EH, which one are you asking about?
No, because you went from F to C and crossed or went over the line.
It's back. Point F is back here, so it's really behind. Because EH would be here. F C is back here if we looked at it from the side. So it's actually behind it. Yeah, no, it's behind it. Yep. So let's look at these here. lines parallel to GH and through point F. So it would be a line parallel to GH and goes through point F. Yes. Because we're talking about two lines that are parallel. So the bottoms of this rectangular prism would work.
What about DC?
DC would be parallel to GH, but it wants it to contain the point F, so it's going to want that one. Now, if it just said name a line parallel to GH, then DC and EF would both work. Now, if we want to name lines skewed to GH containing point F, well, we know F is going to be one of the points, and B, yes. Now, say it didn't have to contain point F. We could do FB, obviously, AE, or AB. Because any of those three that don't intersect the plane are contained in that plane, or plane, this side plane, or the bottom one, would be skewed. All right, how about the line perpendicular to GH and goes through point F? Yeah, because most likely on these here, because it tells us the point, it's going to be contained in the naming of the line or plane or whatever we're doing. Well, plane or planes parallel to GHD and contain point F. So, well, we can say plane F, because GHD is going to be this here, contains point F, would be what? This end over here. So what other two letters could we use? And, yeah, because we could have said FEA, FBA, FBE, any 3 points that are contained in that plane. Questions on this here? Are you ready for the next thing? Now, this here is not in your notes. Yes, sir. Perpendicular means that they intersect at a right angle. Yes. That they may intersect at a right angle. Well, through a point not on a line, there are infinitely many lines that will intersect or cross that we can make. For any point in a line, we can make an infinite number of lines through that point. But the parallel postulate states if there's a line and a point not on the line, so just a line and a point, there's exactly one line that goes through that point that will be parallel to the given line. It's a convoluted way of saying, like, if I have a line and a point, I can only draw one line through it that's going to be parallel to the given line. Also, the perpendicular postulate states if there is a line and a point not on the line, then there's exactly one line through the point that's perpendicular to the given line. So given a line and a point, I can only draw one line through it that's going to be parallel and one line that is perpendicular. And that's all these are saying. So that means if I have a line and a point that two are parallel, any other line through that point will not be parallel. Or if I have two lines that are perpendicular, any other line through one of the points is not going to be perpendicular. So, now, name a pair of parallel lines. It might be very tempting to say that BM or BF is parallel to CD or CE. but we don't have enough information to say that. The one that we can say is that DM is parallel to EF. Now, the way that I can say that is because of these right here. Those little arrow markers tell me that these two lines are parallel. And the number of arrow markers that we have corresponds to the other line. So if I have one on one line and another one with one, those are parallel. If we have two, the ones with two are parallel. If we had three of them, the ones that have three arrows would be parallel to each other. Because if we think back to when we talked about congruent segments and we did one mark and one mark to show that they were congruent, it's the same thing. They're just using arrows to show that these two are parallel. Because what I could do is add another line up here and this line here and do one, saying that these two lines are parallel to each other because they have one of the parallel marks on them. And these are still parallel because they have two. They match up. Now, when we're naming perpendicular lines, we're looking for a what? Are there two lines in this figure that intersect at a right angle? One of them is. It's parallel to BF. And this really should be a ray technically, but DM is parallel to BF because it has that right angle, yes? But that also means that any other line that intersects DM and BF at point M will not be perpendicular to it because from a given line and a point, not on that line, there's exactly one line perpendicular to it. So really we could say BM has only one line perpendicular to it given point D, which is the ray D. Yeah, there's only one for it. Yes. So these two are perpendicular. Now, these two here are parallel to each other. Parallel to. Mhm. Oh, EF. DM and EF.
I mean, B. Question B. Name a character.
Perpendicular. So DM, B, F. F is down here. So this line and this line. Because of this right angle here, it's saying that these two cross at a right angle, so it makes them perpendicular. Oh, thank you. There. Let's put the right symbol. Thank you. That makes more sense. There's sometimes I'm too focused on other things, I'll miss that staring me right in the face. Thank you.
Upside down. Looks like a sword. Yeah.
Any other questions on this here? Let's focus back in, Logan.
Sorry.
You're good. Any other questions on A or B? Is FE parallel to AC? No. Because FE and AC, no, because they will cross. But AC does go through point M, yes? Because AC goes through point M. Now, according to our postulate, given a line and a point not on the line, there's exactly one line that's parallel to it. Well, we already said DM is a line parallel to it. So any other line that goes through point M will not be parallel to it. Or it will cross, yeah. So this here would be no. Any other questions on this here? And we're not going to focus too much on example 2. Yep.
Wait, what's that example two?
It's just using the same thing what we just said. So perpendicular, because given a line and a point not on the line, there's exactly one line that will be perpendicular to it, so the other one can't. Looking at this here, can you name a pair of parallel lines? L and G. H, L, and G. I was, especially first hours, I was tempted to say GM, but point M is right there. So GK is parallel to HL. Those two would be parallel to each other. And the way that we know it from the diagram is our arrows. The arrows that were drawn on the line, they tell us that they're parallel.
Were arrows there?
Oh, they're also in the note sheet. Name a pair of perpendicular lines. So perpendicular intersect at a right angle. Okay. So there's a right angle here. So we could use GK, and it's going to be perpendicular to? Yes. Because we could say LJ, LK, KJ, or KL. Because any of those 3 points are contained on the line. As long as we describe this line here. Any other questions on this here?
Whenever you had all three of them marked,
Mhm.
well, yeah, but
Yes.
I thought Freddy two had three.
Last one, guys. GN is GN perpendicular to JL?
No.
No, because it doesn't intersect it at a right angle. And we also know that given LJ and point G, the line GM is the only one that will be perpendicular to it. Questions on this here? Okay. This is the last thing we're covering today.
We'll get to watch the video of
Corresponding angles. Corresponding angles. Two lines that are cut by a transversal. Two angles are corresponding when they have the corresponding position. So we can say same position. They're in the same position. So if I have two lines and a line that intersects them, that line is considered to be the transversal. Now angles in this setup, like we have here, are in the same position. So if I look at angle 2, well, it's above the line and to the right of the transversal. Yes? If I look at 6, well, it is above the line and to the right of the transversal. So they are in the same position. They are corresponding. They're on the same side of the line and same side of the transversal. So they're corresponding. Alternate interior angles. Well, if we look at this here, 4 and 5 are both inside. Yes, interior between the two lines. And alternate means opposite. So 4 and 5 are between the two lines and on opposite sides of the transversal, yes? So they're alternate interior. And that's it. Alternate interior angles. Inside and opposite sides. So alternate interior, they're inside the two lines and on opposite sides. What do you think this one's going to be called? Well, they're opposite, aren't they? They're not between, they are opposite outside, so they're alternate exterior because they're on opposite sides of the transversal and they are outside the line, so that would be alternate exterior. Net exterior angles outside and opposite sides of the transversal. And the last one is consecutive interior angles.
Does that mean it's like across? Because maybe the numbers are on the inside, is that the reason?
Same side and
Inside.
they're on the same side of the transversal and they are between the two lines. Now we don't talk much about corresponding or consecutive exterior angles because they'd be on the same side of the transversal except outside. Questions on this here? Okay. So the first thing we're going to look at is we're going to name all the corresponding angles. Okay? So let's just start off with, say, angle 1. So angle 1 here is above the transversal and to the left, yes? So if I look at the other set of angles over here, which other one is above? So above and to the left? 5. Because above and to the left, so it would be 5, yes. Now, angle 2 and what angle? 6. Because it's above and to the right would be 2 and 6. How about 3? Because 3 is below and to the left. 7 is below and to the left. 4 and because it's below and to the right, then we find below and to the right. They're in the same position, yes? So they correspond to each other. That's it. Alternate interior. So between the two lines, so we're looking at 2, 4, 5, and 7. So it'd be angle 2 and, because alternate, so they're on opposite sides. So 2 is opposite, because 2 opposite and inside. Because the opposite, so we're going across and over is 7. Now 4 and what? 5. Because 4 is below, so the other one would be opposite above. Questions on these here? Alternate exterior. So exterior would be outside. So we could say angle 1 and 8. Because the 4 in themselves, the ones that are all on the same line, really aren't going to connect to each other for these 4 here. So 1 and 8, opposite sides, outside. 1 and 8. The other would be outside the two lines and on opposite sides of that transversal. Consecutive interior angles. So between 2 and, not 4, 2 and 5 and 4 and 7. Because consecutive are going to be on the same side in between. Consecutive interior on the same side of the line. Tyler. And either both above or both below. Questions on this here? Okay, that's fine.
That looks fairly easy. You just gotta know the words. What they do. How to do it. It's easy. You just gotta do it.
Consecutive interior angles. Consecutive interior means on the same side, in between. So 8 and, yes. Because 8 and 7 are between the two lines and on the same side of the transversal, so they would be consecutive interior. 3 and 4, because those are the other two that are between the two lines and on the same side of the transversal, the line cutting through them. Alternate exterior, so we're talking about the angles outside. What's one of the angles outside? And it's 5. 1 and 5 are both outside and on opposite sides of that transversal. One's above the line, one's below. So they're alternate exterior. 2 and 6. 2 is below, 6 is above. So they're alternate exterior. Corresponding, this is the one we have the most. We can start out with 1 and 2 and 3 and 8 and 6. Because they're just matching up. Because 1 is above and to the left on the other line. 7 is above and to the left. 2 is below and to the right. 4 is below and to the right. 3 is below and to the left. Well, 5 is below and to the left. And lastly, 8 is above and to the right. So 5 is above and to the right. They match up. And the last one, alternate interior angles. Would be and 4, then 3 and that's it. Questions on these here? This is the last piece. Now, all we're doing here is they've set it up for us. We have to name it. So here, 1 and 5 are what kind of angles? Corresponding, alternate exterior, alternate interior, or consecutive. So alternate interior, exterior, either they're both inside or both. So alternate interior, exterior, they're either both inside or both outside, yes? Are they both inside or both outside? No. One's inside, one outside, yes? Well, that takes out alternate interior, alternate exterior, and consecutive. They're both inside, yes? So the only one that we have left is corresponding. And if we look at it, well, 1 is above the transversal and to the left. Where's 5? Above and to the... They're both in the same place, yes? So it's corresponding angles. Now this next one, 2 and 7, they're both outside, so we would have exterior, and they're on opposite sides of the transversal, so they are alternate exterior angles, because they're outside and opposite each other. So we just put alternate exterior angles. Questions on this here? Very good. Awesome. And lastly, this one here. Yes. Alternate, because they're not on the same side of the transversal. Because one's over here and one's over here. And they are on the inside. Interior. I don't think I spelled that right. INT IOR, interior. Angles. Now, these here do gain a special property to them when the lines are parallel, when the two lines are parallel. But we'll cover that at a later date. Yes. Make sure to get the homework down. Yes. So the homework is on page 117, problems 3 through 18 and 20. 3 through 18 and 20.